God plays dice with the universe. Even stranger, our universe isn't real. At least, so says one interpretation of quantum mechanics. The Copenhagen interpretation of quantum mechanics doesn't claim to know what's really going on under the hood. Rather, as David Mermin summarized, just shut up and calculate. The idea is that the mathematics of quantum mechanics tells us how to predict what the outcomes of quantum experiments are, and, at least for now, that's all we can hope for from scientific theories. Philosophers call this type of perspective instrumentalism. So what exactly does the Copenhagen interpretation say? First, it says that the measurement of a quantum system leads to an irreversible event called wave function collapse. That is, measurement plays a special role. Note, however, that this is not meant to imply that consciousness plays a role, rather that there is a special notion of a classical measuring device interacting with a quantum system. Second, when quantum measurements occur, the outcomes are truly random. We can say things about the likelihood of certain outcomes, but we can only ever establish statistical probabilities, not certainty. Third, that it's not meaningful to talk about the result of measurements that are not made. Often this is described by the lack of realism. This has a very specific meaning, namely that the properties of quantum systems are not necessarily defined prior to their measurement. Now, this doesn't mean that the moon doesn't exist or whatever. This solely applies to quantum systems, which, in particular, the Copenhagen interpretation distinguishes from classical systems. Importantly, all of these claims are perfectly consistent with experiment. In fact, this is the interpretation that's taught at basically every university, because using this interpretation is really easy, and it will always give the right answer. The trouble is, there are problems with the implications of these claims. Most problematic is that it doesn't claim to explain what the difference is between a classical object and a quantum system. Surely, classical objects are just many quantum objects considered together, so why is there a special interaction when there are many quantum objects? This problem in turn leads to many serious issues that seem to spell the end of the Copenhagen interpretation if we attribute ontological status to its features. One such thought experiment is the Wigner's friend thought experiment. Nonetheless, this is the most popular interpretation of quantum mechanics, and that's because most physicists just acknowledge that it's not necessarily describing something fundamental about nature, it just happens to agree with what experiments tell us. Don't worry about why it works, they say, just shut up and calculate. And so we do. But as far as I'm concerned, it's not very satisfying. Physics should tell us something true about the natural world, so I prefer the many worlds interpretation.